Hey, we are going to talk about some special right triangles today. Last class or last video, we got to talk about some triples like the 3, 4, 5 right triangle, for example. We are going to find some more patterns that we can exploit just like those. Okay, the first one that we're going to talk about in part 1 of the notes. Okay, we're going to do the 45, 45, 90. This is going to be in part 1. And then we'll do 30, 60, 90 in part 2. I don't know about you guys, but my kids have not had any work time. So we're going to break this up over 2 days so we can get some work time in class so we can ask some questions. All right. So the diagonal of a square divides it into two congruent isosceles right triangles. Since the base angles of an isosceles triangle are congruent, the measure of each acute angle is 45 degrees. So what it's saying is that if I have a square and I do a diagonal and I'm chopping a 90-degree angle in half, like if this whole thing is 90, then each of these little baby angles is going to be 45 degrees. Okay, that's what it's saying. So another name for an isosceles right triangle is a 45, 45, 90 degree triangle. Now, instead of talking about the side lengths, this is talking about the angle measures. So these special right triangles aren't side lengths, named with side lengths, they're named with angle measures. Okay, so we can use the Pythagorean theorem to find a relationship among the side lengths of a 45, 45 degree right, 45, 45, 90 degree right triangle. Let's talk about why that works. Let's use this little triangle that they've got right here. Instead of having, well, I'll draw my own. That way I don't muck theirs up. Okay, pretend that that's perfect. Okay, let's pretend that this leg is 1, this leg is also 1, and we don't know our C. But we know it's a right triangle. So these two are congruent, so this is a 45-degree angle. Let me do this in blue. This one is 45 degrees, and this one is also 45 degrees. And this one's obviously 90. So the Pythagorean theorem says that if I do 1 squared plus 1 squared, it will give me my C squared. Well, I know 1 squared is 1, add another 1, and I should get my C squared. Well, 1 plus 1 is 2, so my C squared is 2. And then I have to take the square root plus minus, I only want the positive one, but 2 is not a perfect square. Nor does it have any perfect square factors other than 1. So the square root of 2 is its simplest form. So this C is square root of 2. And if you want, you can write a little 1 in front of it. So what we're saying is that if this side is 1 and this side is 1, then its hypotenuse has to be 1 square root of 2. If I make this side 2 and this side 2, then this one turns into 2 root 2 because I just double everything. So we get this beautiful pattern where no matter what I pick as my L's, my sides, I get that same coefficient in front of a square root of 2 for my hypotenuse. That's where it comes from. Okay. So we're going to do these a little bit out of order. We're going to jump around a little bit. So here is my hypotenuse. Here's a leg. This is my L. Okay, this is my hypotenuse, H. Capital H. Okay, and this is my other leg. So my other leg also has to be 8. So because this is a 45, 45, 90, I know that my x has to be 8 square root of 2. Guys, that's it. That's all we do. I know, right? Okay, we're not going to do B yet. We're going to do that one second. I'm going to show you another little cute one. Let's say that I have this little beauty. Okay, this is my right angle. I tell you that these two sides are congruent. Whoops, no, I have to tell you what they are. No, I don't have to. I only have to tell you what one is. Okay, this side is going to be 10, and this side is going to be my x. Okay, because I said that my sides are congruent, I automatically know that my base angles have to be congruent. That makes this a 45, 45, 90 right triangle. So this guy has to be 10, and my x has to be 10 square root of 2. So nice. Okay, now you get it, hopefully. Let's look at C. Okay, this one's a little bit weirdo. Here, let me put the whole thing on so you can see the other ones. All right, this one's a little bit weirdo. So here's my leg. Okay, my other leg is also 10 root 2. And this is my hypotenuse over here. So I have to put this whole leg in front of the square root of 2. So this is my leg, 10 root 2. And then I also have to put the times root 2, just like I put this times root 2, just like I put this root 2. Okay, now if I have a root 2 times a root 2, that just makes a regular 2. So that's 10 times 2. Because root 2 times root 2 is root 4, right? And we know the square root of 4 is 2. That's why. And 10 times 2 is 20. So my x is 20. Now, what if they had given me the opposite kind of information? Let me draw this smaller. Sorry, that's too big. It's too big. Go back. I want you to draw this too. Okay, let's say, for example, that they had told me here's a right triangle. I know my base angles are congruent, so they're both 45. I didn't say that, but this one's 45 and this one's 45. If they mark them as congruent, they have to be 45 because they all have to add up to 180 degrees, right? The 90 and the two 45s. All right, so I've got my two congruent base angles that are both 45, and let's say they gave me 20. How would I then find my leg? Well, I have to take out this square root of 2 that's been multiplied in there. I would have to take, instead of taking L times root 2, I would take my hypotenuse and divide by root 2. Okay? So that gets us into a position where we have to rationalize our denominator, which is why we did that in our review on the first day of notes. So now we have to do, okay, root 2 on the bottom, root 2 on the top, okay? These cancel, these make a 2, so I get 20 square root of 2 over 2. 2 goes into 20 10 times, so that is 10 root 2. And that's how we get back to this L. Okay, so sometimes we'll have to divide by the root 2. If they give us that hypotenuse, we'll have to divide by the root 2. Let's look now at letter B. So if you look at B, B is just like the little picture that I drew down here. Like B. So when they gave us our hypotenuse as 5, we don't multiply by root 2. We're going to have to divide by root 2. I used to hate that when I was a kid. When they give you the leg and you find the hypotenuse, the world is beautiful and you just multiply by root 2, you're done. But if they give you the hypotenuse instead, you have to divide by root 2. And then it kind of sucks a little bit. I'm sorry. Okay. So I have to do that rationalizing thing where I multiply by root 2 over root 2. Okay, so that gives me 5 root 2 over 2, because these two make a 2. Oops. And that's it. X equals 5 root 2 over 2. Okay, that one was a little nasty. I'm sorry. All right, we get another shot at it. Do you see here that we're given the same information? We have an isosceles right triangle where our base angles are congruent. They're both 45. So if this is x, so must this be x. It's basically the same picture. Only instead of 5, we have 16. So we have to do the same thing. We have to take our 16, divide it by root 2. We have to take that factor out. So if I'm dividing by root 2, now I have to rationalize and do root 2 times over root 2, which is just my fancy 1. I'm multiplying by 1. Okay, that gives me 16 root 2 over a 2. Now, on example B, 5 was not divisible by 2, so I got to be done. Okay, there wasn't anything else I can do. But we know that 16 is divisible by 2. 2 goes in 8 times. So my final answer for my x is 8 root 2. Okie dokie. Jana is cutting a square of material for a tablecloth. So I already know that I'm going to need a square. Okay, the table's diagonal is 36 inches. She wants the diagonal of the tablecloth to be an extra 10 inches so it will hang over the edges of the table. What size square should Jana cut to make the tablecloth? Hold on, I just beeped. Okay, so I reread this problem and it's more exciting than we originally thought. So that's my table. My table has a diagonal of 36 inches. Now I'm cutting a tablecloth. we want the diagonal of the tablecloth to be an extra 10 inches long. So that means that we want an extra 5 inches over here and an extra 5 inches over there, for a grand total of 46. Right? 5 and 5. So I need another square for my tablecloth. Whoops. I was trying to draw a square. Okay. Okay, good enough for rock and roll. Okay, so my diagonal is 46. Okay, so here is my L. So really, the important thing we need to know is that I have a diagonal of 46, and I have a right triangle that's a 45, 45, 90. So this is one where I have to divide by the square root of 2. So I'm going to take 46 and divide it by the square root of 2. So that means I have to multiply top and bottom by root 2 to rationalize. That gives me 46 root 2 over 2. 46 is even, so I can divide by 2. 46 divided by 2 is 23 root 2. Oh, and it says to round to the nearest inch. So I got to use my calculator for that. So, oops, that's not my calculator. 23 root 2 is what I need to do. 23 times the square root of 2. And they said the nearest inch. So I don't have a decimal. It's like my whole inch. So 5 and up, we round up. So this should be 33 inches. Round to my length is 30. Was it 30? Oh my gosh. No, 33. Jeez Louise. 33 inches. Okay. That's it. All right, Tessa's other dog, is wearing a square bandana with a side length of 42 centimeters. Oh, what would you expect the circumference of the other dog's neck to be? I don't know if I have enough information for this one. Okay, yeah, I reject the premise of this problem, but we'll talk about that in a minute. Let's just crank it out and see if we can figure out what they're talking about. All right, a square bandana. Square bandana. Ew. Let's make it a red bandana. Okay, we want the side length to be 42 centimeters. Okay, this is a square. Okay, what would you expect the circumference of the dog's neck to be? Okay, so in order to tie this thing around the dog's neck, what you're going to have to do is fold it along this diagonal. Fold it. Okay, and then you're going to tie the little ends. So if you can watch me down here in my little camera. Okay, here's our pretend bandana. I'm going to fold it, and then I'm going to tie it around the dog's neck. So the diagonal has to match the dog's neck. That's what's happening. So this is the neck. So if this is a 45, 45, 90, which it is, this is a 42 centimeter side. So all we have to do to get the neck is multiply by the square root of 2, because it should be L root 2. So I just have to do 42 root 2, and I'm done. So neck equals 42 root 2. Oh, and they said round to the nearest centimeter. So we're going to round to 42 root 2. We're going to say 59 centimeters. Round to 59 centimeters. Now, this problem is inherently flawed because, let me tell you why. This is why I was getting upset, like we don't have enough information. Like if I'm going to tie this around the dog's neck, I've got to have room to tie it. I've got to have extra, right? So if I round down, not only is it not going to touch, it's going to be like, and not even touching. I'm certainly not going to be able to tie it. So I don't like this problem. I think it's dumb. So there you have it. But we're done. I reject it.